Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And hi everyone. So today we are going to proceed with our third week. We're introducing to you the material balance without reaction. Okay. For the previous part on Monday, I give it to you the quizzes where the slides is inside there. Okay, there is no lecture video that I given. Alright, so actually the main purpose I did that is to give all of you a practice to read the notes. Okay, and the notes actually is not very difficult where you need to follow step by step. Okay, it may have a lot of slides, but actually it just repeating slide where it shows step by step, so it's easy for you to follow. However, if you want me to repeat again, please let me know lah. Okay, so without further ado, we're going to proceed with the next lecture. Okay, for this week, for this topic on this current topic, what you need to you should able to apply the general mass balance equation. Okay, and secondly, you should know how to compute or how to how to use the degree of freedom for chemical engineering problems. Alright, okay, so we are going to learn about conservation of mass law, where it stated that mass cannot be created, cannot be destroyed, it only can be transferred or transformed. Okay, let's see for the first example here. Okay, for this example, if you notice at 2001, where you have a large of big of television, and the audience, or maybe is you, is very slim, thin. Okay, but where the year goes by, at 2017, where 16 years later, your television become more thinner, but your body become fatter. Okay, so the mass from the TV at 2001 is transferred to your body, okay, at 2017. So even though if you look only at the if you look at the television itself, yes, the mass is, or the volume is decreasing, but to where? Okay, it cannot just disappear like that. Okay, so in this situation, the mass or the volume is transferred to the man sitting in front of the television. Okay, it's just a simple example lah. Okay, the second example is where you have a cup of water, and inside it you have an ice cube. Okay, uh, let's say at the beginning you have ice and ice cube, ice cube and also the water, right? By the time time to time, your water, you are going to notice that your ice cube going to lose their size. Okay, when it loses their size, where is the mass goes? Okay, so it actually melted from the solid, become a liquid. So that's why even though the shape of the ice cube disappeared, but it cannot just disappear like that, but it's transformed into a liquid form. So that's why you have same mass. Okay, all right, understand? So you have to bear in mind, mass cannot be destroyed. Okay, it cannot disappear just like that. It must be transferred or transform to another type of form lah. Okay. Alright. Next. So in that case, where we know that the mass cannot be destroyed or dissipate like that, then we can conclude that the total mass input must be equal to total mass of output. Okay. Next. Okay. Same equation, same example. Let's make some bread where you want to bake a bread, and your ingredients are flour, eggs, yeast, and also a sugar. Okay, so these are your input, right? And then you mix all together, and then you bake, and then it becomes a bread. All right, so let's test ourselves. Okay, what a unit operation that we have here. Actually, there has two unit operation. One is mixer, and another one is oven. So there's two unit operation actually in this case. This out the input. So you have input of 30 gram of sugar, 50 gram of eggs, 150 gram of flour, and the rest 10 gram of yeast. So these are your inputs. Okay, so what are the outputs? So since we want to make a bread, so your output is 200 gram of bread. So this is your output. So your input is here. Okay. Does this process obey the law of conservation of mass? Okay. If you want to see, uh, is it yes, follow the conservation of mass or not? So you adding up all the weight here. So how much you get? Mm, so if you be adding up, it give you actually about 240 grams of input, but your output is 200 gram. It does not follows the conservation of mass, but we know that the conservation of law of mass actually input equal to output. So where it goes, maybe there is a some so because it wants the possible explanation, right? So the possible explanation maybe there is some inaccuracy in terms of weight. One, there also maybe where some of your ingredients not turn into bread, but then it turns into CO2 or H2O because you are baking, right? You burn something. Okay, some of the ingredient burn something into CO2, something like H2O, something like that. Alright, so these are the explanation, but the conservation of law must be follow. Okay. Next, so these are the general equation for the mass balance where input plus generation equal to output plus consumption and accumulation. So what is input? So you know that anything that enters into the system is called as input. Okay. What is output? Anything that leave the system called as output. These are what you learn from previous 2 weeks lecture. And then what you have three new terms that you're going to learn here, where generation is something that you produce within the system. Okay. Basically, generation where you have a reaction of two inputs. Okay, when you A plus B equal to C, C is your generation, something you generate in new things lah. Okay, consumption, mass that been using up within the system. Same goes consumption, basically use we have consumption when you have a reaction in your system. And thirdly is accumulation, where is something that gradually build up within the system. So how in a process flow chart, this how it looks like. Input equal to output, the same thing, but inside your processed, you have generated something, or you have consumed something, or there is accumulation of something. Okay. Okay, so these are the rules actually you need to remember. If you have if the question stated that is a steady state process, then the accumulation equal to 0. Okay, remember, if that's I repeat, if that question clearly stated that the process is a steady state, then you don't have, sorry, there's not consumption, accumulation, then you don't have any accumulation. Okay. Okay, steady state, no accumulation. Okay, this one is 0. Okay, and if the question state that there's no reaction at all, then your generation and also consumption become 0. Okay, so these are the rules you need to remember. Okay. When encountered any problems, any questions. Okay, steady state problem, then no accumulation equal to 0. If no reaction occur in the system, then automatically generation and consumption also become 0. Then leave your input equal to output. Alright, so this you should remember lah. Okay, next. Okay, uh, this mass this mass balance equation can be divided into two, which are differential balance and also integral balance. So basically, for differential balance, we use for continuous process. Uh, we know that differential balance we use dy dx, right? So dy dx actually, or d dy or dt, something like that. T is at the instant of time. Okay, the x actually t. Okay, is indicate the rate of something at instant of time. Okay, so each term of the balance equation, which is this one, is the balance equation, having a unit of rate. Okay, rate of input, rate of output, rate of generation is a value of at instant of time, or that on that time. Okay, meanwhile for the integral balance, where you have the uh sorry, when you have the when you use the sorry, you use symbol like this, right? From T1 into T2. Remember, you learn in uh, secondary school where you need to integrate something, okay, from T1 to T2. So this actually, the equation for integral balance actually normally apply for the batch process, where T0 where you input something into a process, and Tn is at time of n, okay, is where you collect the product. So that is a between two period of time. Okay, so basically it used for the batch process lah. Okay, so the units not not on rate, basically it just directly is a volume or a mass, something like that. It's not like differential balance just now, it's in terms of rate. Okay, so balance on continuous steady state, as I mentioned right now, if it's stated steady state, then there is no accumulation. Accumulation equal to 0. So that is why you have accumulation to 0. Okay, so these are the final equation lah. Okay. Okay, we go to the example first. So I'm going to repeat how you are going to do step by step how you're going to develop a flow chart diagram. Okay, so 1000 kilogram per hour of a mixture of B and T contain 50% of B by mass are separated by distillation into two fraction. Okay, so these are the unit process. Okay, so basically you have to remember distillation process, basically we have one input and two output, which is one at the on top of the distillation column and another one on the bottom of the distillation column. Okay, so the input are 1000 kilogram per hour. So the rules for the top of your arrow should be your flow rate, mass flow rate or volume flow rate. So these are your flow rate, mixture of B and T, and the bottom of your arrow must be your composition. Since it's stated that cause 0.5 50% equal to 0.5, yeah, kilogram B, sorry, yeah, per kilogram. And of course, because it's equal to 100%, right? So 50% B and 50% of T. So 0.5 kilogram T over total kilogram. Okay, it's division into two fractions, so 1, 2, 1 and 2. The mass flow rate of B in the product top stream. The mass flow rate of B in product top stream is 450. So we have 450 kilogram of B per hour. And T in the bottom stream, this bottom, you have 475 kilogram T per hour. Okay, so basically these are the process flow diagram. Okay, for distillation process, when you want to separate between B and T, okay, let's say this, not let's say, okay, this B and T, you want to separate between B and T, right? One majority of B going to top stream, and the majority of T is going to below stream. However, not 100% of B going to top stream. There is some T that are going to follow B here. Okay, so let's say I put here M. Okay, same goes to T. Not 100% of T going to, not 100% of B going to top of the stream. Some of the B going to follow on the bottom stream. So we have N here, N kilogram of B. Okay, so these are your process flow diagram. Second question is asking write the balance of B and T. So balance of B and T, we follow back the conservation of mass equation just now. Okay, since it's stated steady state, then you don't have generation, and also consumption. Both are equal to 0. So what in the final equation of conservation of law, you are going to get input equal to output. Since this is only distillation, there's no reaction. All right, so there's no reaction, then accumulation also equal to 0. So since input equal to output, we can use B and T lah, because we only have two reactants here, B and T. So first we going to have balance for B, which is 0.5. Okay, B, mass balance for B times 1000 for the input. Output will be, we have 450 on top plus N on the bottom. Okay, so we have here 500 equal to 450 plus n equal to 50 kilogram of B per hour. Okay, so these are the balance for B, and meanwhile for T, the same equation, input equal to output. Input is 0.5 times 1000 equal to M plus output 475. So 500 equal to M plus 475. So what is the flow rate of T? Equal to 25 kilogram per hour of T. Get it? Okay. Next, we are going to learn about degree of freedom. So these are the equation of degree of freedom. Okay. This degree of freedom, this is number of unknown minus number of independent equation minus number of other relation equation lah. Okay, such as maybe in the question it give the relation between density, something like that. Okay, let's say we look at the example for the case 1. Okay, you have x and y, which is your unknown x and y. You have two unknown. Okay, and you also have 2, 1 and 2, two independent equation. So your degree of freedom is 2 minus 2 equal to 0. When you get number of freedom equal to 0, that's mean your problem can be solved. You can find x, you can find y. Okay, so in every chemical engineering problem, you want to have degree of freedom equal to 0. Okay, next, the case is degree of freedom is more than 0, where you have more unknowns, which is you have a lot of things to find compared to equation that you have. Okay, sometimes you miss equation or miss some info provided in the equation, or perhaps that question cannot be solved at all. Okay, example, look at this xyz. So you have 3 unknown, but you only have 2 equation. So degree of freedom here is 3 minus 2 equal to 1. So more than 0, it cannot be solved, or you need to find another equation to make it 0. The next, where you have degree of freedom less than 0, where you have a lot of equation, where you have 3, but you only have 2 unknown you need to find, which is x and y. So degree of freedom for this case is 2 minus 3 equal negative 1. Okay, in this case, that's mean you have a you have a few answer of x and few answer of y. Okay, so we also want to avoid this kind of situation. All right, okay, we follow this one. We're going to try this one. Okay, is this required to prepare 1250 kilogram of solution? Okay, so these are the output lah. Composed of 12% of ethanol and 88% of water. So its aqueous solution contain ethanol and also water. Okay, two solutions are available. The first contains 5% of ethanol and the second 25% of ethanol. So that means it's going to adding up between two inputs. So what is the process? Unit process is only a mixer lah, because it's going to mix. Okay. So you have two outputs and one output. So you want you to produce 1250 kilogram of aqueous solution of ethanol, where you have 0.12 weight percent of ethanol, and the rest is water. Okay, and two solution, where is your input are 5% of ethanol. It's easy for you to change directly. Sorry. Okay, it's easy for you to change directly into a decimal point like this. So here is 0.12% kg of ethanol, and this one is 0.25 kilogram ethanol. Okay, this one, okay, you should know that summation of ethanol and water must be equal to 1. So this one is should be 0.88 kilogram of water per total lah. And this one also should equal to 1, because it's a composition. Okay, either mass composition, mole composition, the total out of composition of that stream should equal to 1. Okay, so this one is 0.75 kilogram of water per total. Okay, sorry. Okay, so we have done draw the process flowchart. This is your process flowchart. Develop the mass balance of each component. So how many components you have here? Okay, you have two components, which is ethanol and also water. So component of ethanol, okay, since you only have a flow rate here, so you need to give a symbol for flow rate, to flow rate of your input. So let's say I put here M, this one N. Okay, so for ethanol, mass balance for ethanol, so you need to, okay, input back to conservation of law, input equal to output. Why? Because this is non-reactive chemical, there's non-reaction occur in the mixer. So where is no reaction, what equals to 0? So your generation and also your, sorry, so when there is no reaction, your generation and also consumption equal to 0. Okay. Okay. Second, you also can state here, assume that the mixing is steady state. When it's then when it's steady state, then you don't have any accumulation. Where accumulation equal to 0, then you can get input equal to output. Okay, actually in your your test or in your final exam, when you have assumption like this, when you clearly stated the assumption, you can get extra marks here. Okay, so back to the mass balance for each component. Since we have two components here, which are ethanol and also water. So we start with ethanol first. Input equal to output. So we have two input, 0.12 m plus 0.25 n equal to 1250. Actually, there's no dot here, okay? Dot when you have flow rate. Since we don't have, this not a flow rate, then no need dot lah. Okay, so this is first components, and the second component is water. So water is 0.88 m plus 0.75 n equal to 125. Sorry, this one 0.12, this one equal to 0.88. So these are your balance. Okay, I'm not going to solve to simplify this, but in your answer sheet you need to simplify lah. Okay, let's see. Find the degree of freedom. Okay, degree of freedom. So how many unknown you have? 2 m and n minus number of equation, independent equation. So basically independent equation is the mass balance equation for each component. So you have two component here, which has ethanol and also water. So directly you have two equation. So 2 minus 2 equal to 0. It can be solved where you can get the amount of the value of m and the value of n. Alright. Okay. So next, number 4, how much of each solution are needs to prepare the desired solution? So you need to solve these two problems lah. These two problems to get the value of m and the value of n. Okay. So perhaps you can try to find a value of m and value of n and comment on give your answer in the comment below. Okay, because you have comments here, right? You can comment. Okay, so you can try lah to find the value of m and value of n. Alright, next. Okay, so these are membrane. Another example of membrane. Membrane represent a relative and new technology for gas separation. Okay, basically membrane can use to separate gas between CO2 or N2, something like that. One of the application is the separation of nitrogen and oxygen from air. The figure illustrates a nanoporous graphite that is made by coating a very thin layer of polymer on a porous graphite supporting layer. Okay, so you have how many input here? So you have one input and two output. Okay, one is called retentate output, another one is called permeate. Okay, draw the process flowchart, develop the mass balance for each component, find the degree of freedom, what is composition of the retentate stream if the retentate stream amounts 80% of the input of stream. Okay, this question doesn't need to be solved, it just want you to compute some equation. Okay, draw the process flowchart. Let's see. Okay, so what is the unit? Process is a membrane where you have one input and two output. Okay, so the input is air. Okay, you know that in air you should have 79% of nitrogen and 21% of oxygen. Okay, please remember this, because in real exam, in real equation, basically when it's stated that the input is air, so you should know automatically the composition of the air, where the composition of the air is 79% of nitrogen and the rest is oxygen. Okay, please bear that in mind. Okay, so this one 0.79 N2 and 0.21 oxygen. So what are the output? You have permeate where you have 25% of oxygen and 75% nitrogen. So here 0.25 O2 and 0.75 N2. Okay, so this one I call it as a permeate lah, P lah. Okay, and retentate we have how much? It doesn't state, but then it's stated here. Okay, never mind. Okay, we have O2 and N2. So directly give your symbol. So maybe you can use here X composition of O2 and Y composition of nitrogen. But this Y actually you can turn in because we know that X and Y, the summation of X and Y equal to 1. Alright, so directly you know that Y can be represented as 1 minus X. Okay, when you use that, when you represent this kind of solution, then you can eliminate one unknown. Okay, less unknown, less independent equation you need in order for you to get 0 degree of freedom, less hassle. Okay, so we directly use 1 minus X of sorry. So we directly take 1 minus X of nitrogen. Okay, never mind lah. Alright, okay, next. Okay, develop the mass balance of each component. The same thing, so we have how many components? We have nitrogen and oxygen. So we left this one. Let's say we call it as I lah, as a input. Mass balance of each component. So same goes, you need to give your assumption since this is non-reactive or no reaction occur, so there is no accumulation. Sorry, no accumulation. There is generation equal to 0 and consumption also equal to 0. Next assumption, you said that it is steady state process. When it is steady state process, then you have accumulation equal to 0. So the conservation of mass equation become input equal to output. So from here, you can do your mass balance equation. So how many components you have? You have two components, which are nitrogen and oxygen. So we start with nitrogen first. So what is your mass balance? Input equal to output, right? This one. So for nitrogen, input is 0.79 I equal to 0.75 P plus 1 over x, 1 minus x of R. Okay, oxygen will be 0.21 I equal to 0.25 P plus X R. Okay, sorry. Next, find the degree of freedom. Degree of freedom equal to number of unknown minus number of equation. So from here, actually, you have a lot of unknown. You have 1, 2, 3, 4. 4 unknowns minus equation. How many equation actually you have? 2 only. So you have 2. When you have degree of freedom more than 2, can you solve this problem? No. You cannot solve this problem. You need to find another equation or another info that can develop another equation. So we go to 5. The next. Okay, next. What is the composition of the retented stream? Okay, if the retented stream amount is 80% of the input stream. So here is stated that retented stream equal to 0.8 input. So we have another equation. R equal to 0.8 I. So from here you can substitute into your equation. Can you solve this problem? Actually no, because you still need another one equation. So because this one another equation, right? So plus this one equal to 3. Okay, your new degree of freedom 4 minus 3 equal to 1. So you need to find another one, or the question actually need to give you another uh, info in order for you to solve this kind of problem. Alright, okay. I think that's all for this one, for this lecture. I'm going to give you another some equation, some questions for you to practice. No need to submit. Um, just for you to practice lah. Actually, practice make perfect. So please try in PDF. Please try to make the sample questions. Okay, is on your own effort. Okay, that's all from me. Thank you, everyone.